Okay, step number one to naming your organic chemicals, you're going to identify and name the longest carbon chain. You're going to identify and name the longest carbon chain containing your main functional group. This is called the parent chain. Okay, so look for your main functional group. You want the longest number of carbons that connect together with that functional group on it. This carbon chain that has the most number of carbons, it just gets a special name. It's called your parent chain. Now, the way you figure out the name is by putting a prefix together with a suffix. Your prefix that you choose depends on the number of carbons. Okay, so you're going to figure out what the longest number of carbons is, count how many there are. That's going to tell you what your prefix is. And your suffix depends on your functional group. Your suffix depends on your functional group. Okay. Now, table 1 in your module 7 notes tells you the prefixes you're going to put. The suffixes I'm going to tell you when we fill out our summary table. Yeah. This is for naming your numbers of carbons. Okay. If you see 1 carbon, the prefix is going to be meth. Grab this down because you're going to need it. I will be scrolling away from this. 1 carbon is meth, 2 carbons is eth, 3 carbons is prop, 4 carbons is but. Numbers 1 up until 4 are the ones you need to worry about remembering. 5 up until 8. Don't worry about 9 and 10. 9 and 10 aren't specified in the syllabus. The syllabus tells you to go up to 8. Numbers 5 up until 8, you don't have to worry so much about remembering because it's the way your 2D shapes are named in maths. Yeah. So 5 pent for pentagon, 6 hex for hexagon, 7 hept for heptagon, and 8 for octagon. So the only ones you really have to worry about remembering are the first 4. 1 meth, 2 eth, 3 prop, 4 but. Okay. Your first homologous series that I'm going to introduce you to start practicing step 1 is an alkane, which has a carbon-carbon single bond, and the suffix you use is ane. The suffix is going to be easy to remember if you remember the homologous series. It's just the way the homologous series ends. Okay? If it's carbon-carbon single bonds all throughout, you just finish it off with ane. So, can you set your chat all to me for the entirety of today's lesson? Everyone's going to be able to get involved with this. I don't need your answers aren't going to take too long to come in. So let's say I gave you something like this. I'm going to start you off simple because this is only step 1. If you want all of your steps together, you might want to flick over to a next page as well if you want to jot down these examples. Yeah. So leave that first page for all of your steps because there's going to be a few examples that we put in. You might want to start the examples on the next page. What's the longest number of carbons you see connected here? 4. The prefix for 4 is but, and everything is a carbon-carbon single bond. I've only given you one suffix so far. What's the suffix for a carbon-carbon single bond? Set your chat all to me. It's going to be ane. Good. So this is just butane. Okay. Step number 2. If you've already done this at school, you'll notice I'm gonna add a little bit of detail to the steps that we're doing today to avoid absolutely any confusion that we're having. Yeah. You're going to, you don't need, I'm going to add this step in for now. You're not going to need step 2 for a little bit, but it's in order. You're going to remove the E and replace with the suffix for the main functional group. Step 2 won't make much sense at the moment because I'm not going to change the functional groups that much. Yeah, jot step 2 down for now and it'll make sense as we go. Once again, if you've already done this at school, I'm adding extra detail to avoid any confusion that we've been seeing in the other classes. Yeah, leave step 2 for now, jot down step 3. Step 3 is to number your carbon chain. To give your main functional group the smallest location number. Number your carbon chain to give your main functional group the smallest location number. Separate your numbers and letters with a hyphen. Okay. And then I'm going to add detail to the steps so that you have everything. You don't have to, you can have everything on the same page. Place your number before the suffix for your functional group. So earlier we said, oh, you have a prefix and you have a suffix, and normally you just connect it together, but you have to put a number before that suffix. So it's going to be prefix hyphen number hyphen suffix. Okay. I'm adding all of the little details so you have it all on the page and there's no confusion. All right. Your second functional group is an alkene with a carbon-carbon double bond. The suffix is -ine. Your third homologous series is an alkyne. The functional group is a carbon-carbon triple bond, and the suffix is -ine. Cool. So we're going to make use of step 3 now. Let's say I gave you what's the longest number of carbons you see here? 5. What's the prefix for 5? In one long line, doesn't matter the bonding, as long as you can connect it all, it's 5 in one line. Pent. Now, carbon-carbon single bond is the simplest thing you'll ever see. It's the lowest priority. Do you see anything else a little bit more complex than your carbon-carbon single bond? I see a carbon-carbon double bond. Good. That's an alkene homologous series with a double bond functional group. What's the suffix if it's an alkene? -ene. Okay, cool. I need a location number for my functional group that goes before this suffix -ene. So I'm going to leave a bit of a space here so I can put the name in. You want to number your carbon chain in whichever direction that gives you the smallest number. Okay, if I go left to right, this is my ordering. And if I go right to left, this is my ordering. Have a look here. If I start my numbering from the left in the red, what carbons are in my double bond? What number of carbons are in my double bond when I go left to right in the red? 2 and 3. What numbers carbons are in my double bond if I go right to left in the green? 3 and 4. Okay, 2 and 3 is the smaller combination. So this time I'm going to prefer to go left to right with the red. Now, carbons 2 and 3 are both in my double bond, but I only need one of them in the actual name. Yeah, you're just going to take the smaller number, which is 2. So this is going to be pent-2-ene. I didn't answer your question earlier, Luca, because I wasn't up to it yet. You can decide to do pent-2-pentene if you want, or pent-2-ene. Either way is fine. If your teacher has a preference, go about it whichever way your teacher prefers. Doing it this way, however, is useful when you have multiple functional groups. Yeah. So
Yeah, my teacher, sorry, my teacher did say that like by the traditional conventions, the pent-2-ene is better.
yeah. So if
Yeah.
your teacher has a preference at school, everyone, you can do two pentene. Either way, you'll get this, you'll be marked right for it, but pent-2-ene is a little bit more flexible. You'll see later on when we make it more complex that it's putting it in the middle is going to be easier later on. Yeah, the first way doesn't work if your structure starts getting a little bit complicated. So this is pent-2-ene. All right. Step number 4. Name any branches or halogen substituents. I'll add to this. Name any carbon branches or halogen substituents bonded to your parent chain. Now, if it's additional carbons bonded to your main chain, you call that a branch. If you're naming a branch, you have your prefix, which is the number of carbons, and then you have your suffix. Your suffix for any branch is not going to be part of your summary name, your summary table, okay? Your suffix for a branch is always going to be ill, all right? Da-da-da. Go down here, move this down. If it's a halogen, replace the ene part of the halogen name with O. Okay, so for halogens, you don't have some rule to remember. If it's chlorine, you just turn it into chloro. If it's bromine, you turn it into bromo. If it's fluorine, you turn it into fluoro. And if it's iodine, you turn it into iodo. All right. Okay. And then this is sort of the last of your steps, but I have a few extra dot points to add for your branching and your halogens. First thing I want to note here is you're going to place these names before the name of the parent chain. You're just going to write it down first. Yeah, that's all. Okay. So let's say I gave you what is the longest number of carbons you see connected together with your main functional group, which is the triple bond? Okay, so you've identified this. Whichever way you go about counting your carbons, it has to include this main functional group, which is the triple bond. And the longest one you see is 6 going across. What is your prefix for 6? Hex. Now, this is a triple bond, which is an alkyne. What's the suffix that I use? Ine. I'm going to leave a space because I want to number it. I'm going to number left to right, and then I'm going to number right to left. Which way gives me the smallest location numbers for my carbons in the double bond? For my carbons in the triple bond. Does it matter if I go left to right or right to left for my triple bond? They're both the same. Okay. So I'm going to add a little bit of a note here. If the numbering direction does not impact your functional group, then and only then can you prioritize your branches or substituents. Once again, if anyone's already done this at school, you'll notice that my notes, my steps are a little bit, I'm putting in a lot here. I'm aware of that. This is meant to be concise and include everything you need. Because I've seen with the previous classes, when we go about it a little bit less detailed, I tell you along the way and it's a little bit harder to grab afterwards, yeah? If the numbering direction does not impact your main functional group, then and only then can you prioritize your branches or substituents. What I'm saying is, when you do your numbering, you need to give your main functional group the smallest number. In this case, it doesn't matter. What that means is, you can go about it either way, but if there's branches and substituents, you can then give a smaller number to, you do that, yeah? So I'm going to go back to this. Do you guys see any carbons outside the 6 that I've highlighted? Yes, okay. There's this carbon with a H3 over here. So it doesn't matter for my triple bond which way I number. So now I can start worrying about the CH3. If it did matter, the CH3 would just get whatever number it needed to get. Guys, if I go left to right in the red, what number does my CH3 get? Or what carbon is my CH3 bonded to? My CH3 is bonded to carbon number 2. If I number right to left, what carbon is the CH3 bonded to? It's bonded to carbon number 5. Okay, so this time my triple bond doesn't matter, so I can worry about my branch. I'm going to choose to number left to right. So I'm going to go this way. I'm going to go left to right, which is the red. All right, so I need to finish off my parent chain name first. Hold on. So out of carbons 3 and 4, which one do I put in the name for my triple bond? Clarify what you mean for me, Millen, if you're still confused. 3, cool. And then I can now name my branch. Guys, how many carbons have I circled in my red bubble? 1. What's the prefix for 1? Okay, that's all good. Meth, what's the suffix anytime for a branch? Il. Okay. What carbon did you say the methyl is bonded to along the main chain? Carbon 2. So this is, and then you're going to put it in front of your parent chain name. So this is going to be 2-methyl hex 3 ion. Okay, 2-methyl hex 3 ion. Yeah, that's so good. What did you say earlier? I forgot. Yeah, 2-methyl hex 3 ion. Okay, cool. All right, let's keep on practicing this for a bit before I add anything else. What happens if I gave you what is the longest number of carbons you see connected together? You don't have to go horizontally left to right. You are allowed to change directions. However, you cannot go backwards. Okay, so guys, I'm going to start from the left. 1, 2, 3, 4, and I get to this junction, 5. I can go forward, keep on going to the right, 6, 7. But if I do that, I could have added three more if I went up, okay? You don't have to go in one straight line. It can bend. You just can't go backwards. Yeah. So I'm at 5, 6, 7, and 8. So I'm going to go up this way instead. This is my longest chain. Okay. All right. What's the prefix for 8, please? Oct. Cool. What's the main functional group you see here? All of the carbon-carbon bonds are what kind? They're all single bonds. Good. What is my suffix going to be? Ane. All right. Now, guys, in step 3, I told you guys that you need to give your functional group your smallest location number. Some of the functional groups, based on the way they're defined, do not need a location number. Every single carbon-carbon bond is single. So if you were to put a number, you'd be numbering every single carbon. Yeah. So carbon-carbon single one, I'm going to put a little bit of a note here. You do not need to include a location number in the name. Okay, because if you did, you'd be numbering every single carbon because every single carbon is a single one. Yeah. So alkane is one of the homologous series where its functional group doesn't need to be numbered in the name. It still gets a number, you still go to number it, you just don't need it in the name. Okay. All right. Cool. So I've named my parent chain. I'm going to leave a bit of a space because I know that I have to bring in the branching afterwards. How many additional groups of carbons do you see outside of the 8 that are highlighted? 2. I've got this group here and I've got this group here. Let's name it independently first. This one down here, I've got 3 carbons total, yes, but these two are connected together. I consider that one group, one branch. This one down here, how many carbons have I circled? 1, what's the prefix for 1? Meth. And the suffix for a branch is always "il." What's the number of carbons in this bubble? 2, what's the prefix for 2? F, and the suffix for a branch is always "il." I don't have a main functional group to give a smallest location number to. I don't have a double bond, I don't have a triple bond. So when I go to numbering my chain, I will go in whichever order gives the methyl and the ethyl the smallest location numbers. Yeah, so prioritize your functional groups. Unless you don't have to worry about it, then you can give your branches a smaller number. If I start from the left, oh, I'm going to number this carefully because they're close together. 5, 6, 7, 8. All right. And then other way, starting from the top. All right, have a look at it the red way, starting from the left. What carbons are my methyl and ethyl bonded to in the red? So you're looking at which carbons the CH3 and the ethyl are bonded to in the main chain of 8. This CH3 is bonded to this carbon, and this ethyl is bonded to this carbon. Yeah. So if I go about it the red way, my methyl and my ethyl are bonded to carbons 3 and 5 in my chain of 8. If I go about it the other way, guys, in the green, what carbons are my methyl and ethyl bonded to in the green, if I number it the green way? 4 and 6. Good. Okay, so in the red way, it's 3 and 5. In the green way, it's 4 and 6. Am I going to go green or am I going to go red? If I want the smallest numbers, I'm going to go red. Good. So I'm going to get rid of my green numbering. Red is the priority. Get rid of this, get rid of this, get rid of that. And so then you have, what do we have now? I'm going to put the numbers in front of the names. I've got 3 ethyl and 5 methyl. You've got 2 branches that you've named now. I'm going to go back to your steps and add one more thing. If you have multiple branches, name them alphabetically. If you have multiple branches, name them alphabetically. Okay, so does M for methyl come first or does E for ethyl come first? E for ethyl comes first. So in this case, I'm going to go 5-ethyl hyphen 3 hyphen methyl octane. 5-ethyl 3-methyl octane. Good. Okay. If you have any specific questions, let me know. Jot this down. I'm going to put up your next one for you. The ethyl didn't have the smaller number though. The ethyl got number 5 and the methyl got number 3. So you order it in terms of alphabet, not in terms of the number. Ethyl got 5 and methyl got 3. Oh no, I get what you're saying. You want the smallest combination. It doesn't matter if it's longer or shorter. You just want the smallest combination of your location numbers. That's all good. All right, this next one. What is the longest number of carbons you see connected together? You're allowed to bend the line, but you can't go backwards. Okay, 6. Good. I'm gonna start here. I've got 1, I've got 2. If I go up, I only stop at 3. So I'm gonna keep going to the right. 4, 5. If I keep on going to the right, I only add one more carbon, 6. I'm gonna go down. 5, 6. So this is my chain of 6. What's the prefix for 6, please? Hex. And guys, what's the main functional group you see here? Anything besides a carbon-carbon single bond is going to be higher priority. I've got a double bond. Good. What's the suffix I use for a double bond? Ene. Awesome. Now, I know you see branches and I know you see halogens outside of this carbon chain of 6, but now that I've identified a functional group, I need to give my functional group the smallest number. I'm not going to prioritize my branches anymore. The branches will just get whatever number it gets given. Okay, so this is in the red way, and this is in the green way. Which way gives me the smallest numbers for my carbons in the double bond? The red way. Good. So I'm going to go the red way. My branches and my halogens will just get whatever number it gets given now. I have to worry about my functional group. Okay, so in the red way, carbons 2 and carbons 3 are in my double bond. Which number am I going to mention in the actual name? Carbon 2. Cool. Okay. How many? So the parent chain name at the moment is hex 2-ene. Carbons 2 and carbons 3 are in my double bond. I'm going to take the smaller number, which is 2. How many branches do you see? How many extra carbons besides the 6 that I've highlighted? 2. I've got this here and I've got this here. All right. Now, guys, each bubble has the same number of carbons in it. How many carbons in the bubble? They each have 1 carbon. Good. So I'm gonna end up giving them the same name. They're put in different spots, so they get a different number, but they have the same name. Okay. What's the prefix for 1 carbon? meth, and the suffix for a branch is always "il." Now, I'm gonna add an extra note here. Okay, so all of your steps are done. You've got all of your branches, but there's a few things to say about the branches. Yeah, if you've got more than if you've got multiple, so this previous one was multiple branches any kind. If you've got multiple of the same branch, then you need to add a prefix for the number. Okay, now this kind of prefixing that you add is going to be your normal prefixing. Okay, what I mean by normal prefixing is the prefixing you use normally in real life, not the ones you just learned, meth, eth, prop, and but. Okay, so I just want to say that this table here is for your meth, eth, prop, and but is for counting numbers of carbons. All right. If you're counting anything else, if you're counting the number of functional group, if you're counting the number of branches, you do not use meth, eth, prop, or but. These kind of prefixes are only for specifying the numbers of carbons. If you're specifying number of branches, you use your normal prefixing. You don't need to mention the prefix if it's only one, but just as an example, guys, what's your normal prefixing for one? How do you tell me that something's one? Like when you were naming ionic and covalent compounds in Year 11, Module 1, one is mono. Yeah, what do you use for two? Di, what do you use for three? Tri, what do you use for four? No, hept is seven. Four is tetra. Good. Okay, so if you're counting anything else besides your number of carbons, it's going to be it's going to be the prefixing we normally use when you're naming ionic and covalent compounds. Mono, di, tri, tetra. Okay, so I just want to emphasize your meth, eth, prop, but is for counting the number of carbons. If you're counting anything else, number of branches, number of halogens, number of functional groups, it's always this normal prefixing. Okay. All right. So we identified two branches. They both have one carbon each, so they're both called methyl, which means I've got two methyl groups. I'm not counting carbons, I'm counting methyl branches. What's the prefix that I use for two? We just went through it. Di. So this is going to be dimethyl. Then I'm going to add another note here. Again, I'm giving you all of the little steps so you have it all down on paper and you don't have to keep it in your head. You want a location number for each branch, even if they have the same name. Okay, because what I see a lot of students doing if they see methyl, they just give me one name, one number, even though they're in different spots. Yeah, so you need a location number for each branch, even if they have the same name. Okay, so I'm aware there's two branches, they're both called methyl. I want a number for each of them. All right, you want a location number for each of your branches. Okay, we already decided which way we were going to number. We were going to number the red way, left to right. Tell me which carbons in my chain of six are my two methyl groups bonded to? Two and four. This methyl is bonded to carbon two. This methyl is bonded to four. So I've got two names. This is 2, 4 dimethyl. That's the part. I haven't finished yet, though. I'm not going to put it together yet. All right. Anything else you see besides these carbon branches? Are there any halogens? There's a chlorine here, and there's a chlorine here. Okay. How do I name a chlorine? I replace the I and E part of the name with what? with an O. Good. So this is going to be chloro. How many chlorines are there? 2. I'm not counting number of carbons. I'm counting number of chlorines. What's the prefix I use for 2? It's not F. It's di. Good. And I need a location number for each of them. What carbons are my chlorines bonded to? 2 and 4. Good. Okay. Oh, they happen to be bonded to the same carbons as your methyls. That was just by chance. Okay. This is why I told you to leave a space. Just leave the page for your steps and then start your examples on the next page. I have one more thing to add. Come back to this for me. When you are naming alphabetically, adding on from here, when you're naming alphabetically, you're comparing the first letters of the name, not the normal prefix. Okay, what I mean by that is you're not comparing mono, di, tri, tetra. Okay, if you had to put a prefix in front of your name, you're comparing the letters of the name. You're not comparing di, tri, tetra. Yeah. So what I mean by that is, you know how you named it methyl and then you named it chloro, but then you put the di in front? You are not comparing the D in di. You're comparing the C in chloro and the M in methyl. Yeah, because otherwise it's like, what are you gonna put first? Di or di or di? You're gonna put them on top of each other or something. Okay. You're not comparing the prefix, you're not comparing the letters of the prefix, you're comparing the letters of the names. Yeah. We'll fix that, Luca. It's okay. You're here now. All right, so C for chloro or M for methyl. Which one comes first? C for chloro. Okay, so I'm gonna do my 2,4-dichloro first. All right. 2, 4 dichloro, 2, 4 dimethyl, hex 2-ene. Do you know someone in the class? Or maybe you're talking outside of class, I don't know. So this is 2, 4 dichloro, 2, 4 dimethyl, hex 2-ene. Okay. All right, good. Okay. This is most of your steps. I have one more dot point to add on, but that's a little bit later. All right, let's say I gave you, this is all of your hydrocarbons. You've got your single, double, and your triple bond. Now we're gonna go back to step 2. If you have an extra functional group, you need to get rid of the E and replace it with another suffix. Okay, so this is your hydrocarbons. Your next homologous series, let's go back to update your summary table, is an alcohol, which has an OH functional group. The name of this functional group is hydroxyl, and your suffix is ol. Okay. All right, cool. These are most of your steps. Let's give you another example. Let's go. Okay. When you're figuring out the longest number of carbons, it needs to have your main functional group in it. So you're going to identify your main functional group first. This is the carbon that it's bonded to. When you go to figure out the longest number of carbons, it needs to have this carbon with the OH. Yeah. What is the longest number of carbons you see in this drawing? 6. Good. You can actually just go across. So there's something going down here, but I can just go across this way. 6. And that now contains my carbon with the OH, so this is good. I'm aware that you have that branch down the bottom, that CH2, CH3, but I've got my functional group OH to worry about, so I'm not gonna, my CH2, CH3 will just get whatever number I give it. Yeah. Can you imagine the numbering in your head? Should you number left to right or right to left to give your carbon with the OH the smaller number? Right to left. Guys, if I number left to right, what carbon is with my OH? What number of carbon? Left to right. So I know that's not the way you told me, but we're just comparing. If you did start your numbering from the left, what carbon would have your OH? If I start it from the left, it's going to be 4, but if I do it from the right, I'm going to get 3. 3 is a smaller number, so I will start it from right to left. 2, 3, 4, 5, 6. There's 6 carbons. What's the prefix for 6? Hex. And my carbon chain, scan my carbon chain of 6 for me, single, double, triple bonds of carbons. They're all single. What's a suffix for a single bond of carbons? Hex. I think that was a typo, hexane. So I'm talking about the single bond, which is alkane, which is hexane. Now you've got a main functional group to worry about here, which is the OH. Okay, you were just naming the carbon chain. I haven't named the functional group yet. I've just named the carbon chain, so it's hexane. I'm gonna get rid of the E. What's the suffix if there's an OH? You just added it to your summary table. Oh, cool. And what carbon is my OH functional group bonded to in my chain of 6? Uh, have a look at the numbering again. 3, hexane 3-ol. If you numbered left to right, yes, it would be 4, but we said we'd do it right to left so that it would get the smaller number, 3. And I've got an extra branch here that I haven't named yet. Can you guys give me the name of that one? It's 2 carbons and it's a branch. What's the prefix for 2 carbons? What's the suffix for a branch? Good. Prefix for 2 carbons is F. Suffix for a branch is -il. What carbon in the parent chain is this ethyl bonded to? Carbon 4. So this is 4-ethyl. And I'm going to put it together now. This is 4-ethyl hexane 3-ol. Okay. Now, guys, the reason why I added step 2 in here and was like, oh, name your carbon chain first and then get rid of the E and replace it with your main functional group is because when we didn't have this here and I just had step 1, there were a few students that would go, oh, the prefix for 6 carbons is hex, the suffix for an alcohol is ol, so they'd end up doing hexol, yeah? But you need your regular suffix for the carbon chain first, an, ene, or ol, and sorry, an, ene, or ine, for alkane, alkene, or alkyne, and then just get rid of the E and replace it with the new suffix, yeah? So that was why I added step 2 in there. Name your carbon chain first, get rid of the E, then put in your suffix after, yeah? Because otherwise, sometimes students would just do hexol instead of hexanol. Okay. All right. Cool. An easy one. What's the longest number of carbons here and what's the prefix? The carbon chain has single, double, or triple bonds. Single, so ane. But I've got an OH here, so I need to get rid of the E. What suffix do I use if I've got an OH? Oh, good. Should I number left to right or right to left to give my OH the smallest location number? Right to left. Okay. So Asha, how come we're counting backwards? It's not because it's not that you're counting backwards, it's that you're starting your numbering from the right. I'm starting my numbering from the right to give my main functional group the smallest number. So same thing here. If I start from the left, my OH is bonded to carbon 3 if I number it this way. But if I start it from the right, my OH gets
Ah,
carbon.
like you want to get to the smallest carbon,
Want
yeah?
to give it the smallest.
Ah.
So I'm going to start from the right. This is just going to be propan 1-ol. Okay. Very good.